All right, so get this, we're going deep today. Deep dive into AI. Well, specifically, how we might be able to recreate an AI as powerful as OpenAI's O1. We've got this research paper, right? And it really digs into the technical details, explores how O1 may have been built using reinforcement learning.
Yeah, it's kind of like uh, reverse engineering a masterpiece.
Yeah.
This paper, it's like a roadmap breaking down O1's architecture into four core components: policy initialization, reward design, search, and learning. Like a blueprint to potentially build our own super smart AI.
Yeah, exactly. And we love a good blueprint.
Yeah.
So policy initialization, what is that all about?
Well, imagine like you give the AI this crash course in language and reasoning before it even starts learning on its own. That's policy initialization, mountains of data. Pre-training, it's like teaching it the alphabet and grammar, so it can eventually write a novel.
Okay, got it. So it's giving the AI those basic tools, right, to process and understand information. But what makes O1 special?
Well, what's fascinating is O1 exhibits 6 human-like reasoning behaviors. Things like problem analysis, breaking down tasks, proposing alternatives, even self-evaluation and self-correction. It's not just data processing. It's learning how to think.
An AI that can double-check its own work. That's pretty crazy. How does it even learn these seemingly human skills?
The paper suggests techniques like supervised fine-tuning and clever prompting.
Yeah.
It's like giving the AI mental tools and showing it how to use them, guiding it in a way, refining its problem-solving ability.
So it's not just about data, but how it uses that data. Got it. But how do we ensure it's learning the right things? That's where reward design comes in, yeah.
Yeah, precisely. Imagine you're teaching a dog a trick, right? Positive reinforcement, a treat, some praise. Reward design, giving the AI feedback on its actions, steering it towards the desired outcome.
So we're shaping the AI's behavior, rewarding it for the right moves. What kinds of rewards, though? Just the final result, or is there more to it?
There's more to it. It's really interesting. The paper suggests O1 likely uses a combination of outcome rewards, which judge the final result, and process rewards. So feedback for each step along the way, meaning that AI is learning from mistakes, but also the entire problem-solving process itself.
Got it. So like a coach who gives you the score, but also technique pointers throughout the whole game. Makes sense for complex AI problems. So solid foundation, reward system guiding its learning. But how does it find solutions? That's where search comes in, right?
Yeah, exactly. It's all about the AI exploring different paths,
Yeah.
evaluating their success, refining its approach based on feedback, like navigating a vast, complex maze. The research paper dives into 2 main strategies: tree search and sequential revisions.
Okay, break those down for me. How do those strategies differ?
Well, it's a tree search, right? It's like exploring many options all at the same time, like a tree branching out to cover as much ground as possible. And then sequential revisions, it's about focusing on a single solution, refining it step by step, making incremental improvements.
So brainstorming versus polishing a single idea. I'm curious, does O1 use both of these?
The interesting thing is, the paper suggests O1 may actually use tree search during training to explore a wide range of possibilities. And then during testing, it switches to sequential revisions for a more focused and efficient approach.
Clever. So it learns from many possibilities and zeroes in on the best path during testing. We've gone from basic language skills to brainstorming and refining strategies. What happens next in this AI journey?
Well, by now the AI has experimented, gathered data, received feedback. Time to synthesize all that and learn from experience. This is where learning takes center stage, the final crucial step.
So it all comes together, where the AI levels up, gets smarter, but how does that actually work? Tell me more.
The paper suggests O1 uses a combination of cutting-edge learning methods. Things like policy gradient techniques, PPO and DPO, help the AI learn from successes and failures. And behavior cloning, where the AI mimics an expert. It's constantly reviewing performance, identifying strengths and weaknesses, learning from every single move.
It's like the AI is studying game tapes. Amazing. We've covered the 4 major players: policy initialization, reward design, search, and learning. Seeing how they create an AI that reasons, solves problems, learns, it's incredible. But here's a question. Are there others out there trying to build their own O1?
You're going to love this. There are, and that's exactly what we'll be diving into next. Get ready to explore the exciting world of open source projects.
All right, so we've laid the groundwork, understanding those core components. That might power something as amazing as O1. But now let's shift gears a bit
Yeah.
and talk about those open source projects you mentioned. What's driving them? Who are the big players?
Well, it's really exciting, actually. These projects are all about making O1's power accessible to everyone. It's like democratizing AI, right? Giving everyone the potential to explore and contribute to this groundbreaking technology.
Okay, so it's not just about copying O1. It's about building on it, pushing the boundaries. Can you give us some examples of these projects and their unique approaches?
Absolutely. The research paper highlights a few standouts. Let's start with O1 Journey. They actually went through a couple of phases in their approach. Initially, they focused on using reinforcement learning to refine an AI model's reasoning skills. Imagine this. They generated training data by having the AI explore potential solutions using beam search. And then, they used a more powerful AI, like GPT-4, to give feedback and guide the learning process.
Wait, hold on. So they're using AI to train other AI. That's pretty meta, right?
Exactly. It's like a master chess player analyzing the moves of a novice, right? Pointing out errors, suggesting improvements. And here's a key insight they had. A reward model tailored to O1's architecture actually outperformed a more general one. It really highlights how important the alignment is between the reward model and the AI's learning.
Right, so the reward model needs to be speaking the same language, essentially. But you mentioned O1 Journey had a second phase. What did they do there?
In their second phase, they moved away from reinforcement learning. They tried knowledge distillation. It's like transferring the essence of a smaller version of O1, called O1 Mini, into a larger AI model. They use these clever prompting techniques to extract the hidden reasoning steps of O1 Mini and then use that data to train the larger model.
Okay, so instead of starting from scratch, they're giving the AI a head start. That's interesting. Did it work?
Yeah, the results were pretty impressive. The distilled model actually outperformed O1's preview version on a really tough reasoning benchmark. It highlights the potential of knowledge distillation as a powerful shortcut to AI mastery.
Okay, so O1 Journey is taking this more collaborative approach, right? Using existing AI to train new ones. What other interesting projects are out there?
Well, another one mentioned in the paper is OpenReasoner, familiar with AlphaGo, the AI that mastered the game of Go.
Oh yeah, AlphaGo, a huge milestone, showcased the power of AI. So OpenReasoner uses a similar approach for reasoning tasks.
Yeah, exactly. They're using a combo of Monte Carlo Tree Search, MCTS, and reinforcement learning to enhance the AI's decision-making skills. Think of MCTS as a way for the AI to explore this huge tree of possible actions, simulating millions of playthroughs to figure out the best strategies.
Wow, so the AI is basically playing out all the scenarios, right? Learning from each one. What sets OpenReasoner apart from the other projects?
Well, one difference is they only use MCTS during testing. During training, they let the AI sample actions based on its current policy. It's a bit different from O1 Journey's use of beam search for generating training data.
Interesting. Is there a reason for that specific choice?
It could be about computational efficiency, maybe about encouraging the AI to explore more actions during training. It just goes to show, the diverse approaches in these projects.
Okay, so O1 Journey focuses on knowledge transfer and reinforcement learning. OpenReasoner uses techniques inspired by AlphaGo. What other interesting approaches are there?
Well, there's one more project from the paper that you might find fascinating, slow thinking with LLMs.
The name itself is interesting. Tell me more. What's their approach?
It's kind of similar to O1 Journey. This project is also described in two different reports. The first one details their reinforcement learning approach. They use DPO, a specific learning algorithm, and MCTS for navigating potential solutions.
Okay, so they're combining reinforcement learning and tree search, like OpenReasoner, but with a different learning algorithm.
You got it. But in their second report, they go in a completely different direction. They move away from training from scratch. They actually utilize knowledge distillation to leverage the expertise of existing AI systems like QWQ and DeepSeek R1.
So they're injecting their AI model with the knowledge of these veterans in the AI world, like a crash course taught by the best of the best. Did they see any positive results?
Absolutely. Even with just a limited number of examples from those expert systems, their AI model showed big improvement on challenging reasoning tasks, a testament to the efficiency and potential of knowledge distillation.
So we've got three fascinating projects here. O1 Journey, OpenReasoner, and Slow Thinking with LLMs, each tackling the challenge from different angles. It's like climbers trying to summit the same mountain, but using different routes and techniques.
That's a great analogy. And you know what? This is just the beginning. There's so many other researchers and developers out there pushing the limits of AI.
It's definitely exciting. But before we get carried away, right, let's talk about something that's been on my mind. We talked about O1 excelling in areas like problem solving and reasoning. But what if we could take it further? What if it could apply those skills to any field?
You're talking about generalization, the ability for O1 to adapt and learn in any domain. Yeah, we should definitely explore that more.
Yeah. Imagine AI that can solve complex math problems, but also write poetry, compose music, contribute to scientific discoveries. The possibilities are endless.
You're right, you're hitting on a core aspiration with O1. The dream of a truly general-purpose AI, right? Unbound by the limitations of specialized tasks. And a big part of that is a robust and versatile reward model, one that can provide feedback across a huge range of situations.
Okay, I see where you're going with this. So instead of separate reward models for specific tasks like math, coding, writing, we need a single, super flexible reward model that can handle anything.
Exactly. This general reward model would have to be incredibly sophisticated, able to grasp the nuances of different domains and provide accurate feedback based on the unique goals and criteria of each task.
That sounds like a huge task. How do they even start with something so complex?
It's definitely challenging, but there are some interesting paths being explored. One idea is to train this reward model on a super diverse dataset, covering everything from astrophysics to zoology to music theory. The more it learns about different fields, the better it can assess performance.
So it's like giving the reward model a PhD in everything, right? The more it knows, the better it can guide the AI.
Exactly. And there's another approach that involves using techniques like meta-learning, where the reward model learns how to learn. It develops adaptive strategies for evaluating performance based on the specific characteristics of each new domain.
Wow, so the reward model becomes a master learner itself. But this is all getting pretty complex. There are so many interconnected pieces here.
Yeah, you're right. The AI's success depends not only on its own capabilities, but also on the quality of its reward model, its search strategies, the initial training data. It's this complex system where everything's interconnected and influencing the overall performance.
Right, so we've talked about the technical stuff, but what about incorporating multiple modalities like images and sound into the learning process?
Ah, yes. Multimodal AI things get really interesting there. Imagine an AI that can understand text, but also process visual and auditory information, integrating all of that to understand the world.
It's like going from reading a textbook to experiencing a multimedia presentation. I can see how that would expand its learning capabilities. But what are the challenges in developing multimodal AI?
One challenge is the sheer amount of information the AI has to process. Images, for instance, have way more data than text. So figuring out how to efficiently extract the relevant info from images and connect it to the text, it's a big challenge.
Yeah, it's like finding a needle in a haystack. But the haystack is a high-res image, and the needle is a specific concept. Daunting.
Definitely. And another challenge is the nuances of language, right? Metaphors, analogies, abstract concepts. It's tough to map those to visual or auditory data. The AI needs a deeper understanding of language to connect text with other modalities.
Yeah, it's like explaining a visual concept, say shade of blue, to someone who's never seen color. Tough without that shared visual experience.
Exactly. That's what researchers are dealing with. But there are some cool approaches emerging. One idea is to incorporate visuals and audio directly into the AI's thought process. So imagine an AI that not only reads about an experiment, but also generates images or sounds as part of its reasoning.
That's amazing. Like the AI is sketching out its ideas or humming a tune to think. It's a whole new level of cognitive ability.
Yeah. This could help the AI make stronger connections between different modalities, leading to a more holistic and nuanced understanding. But this is all pretty complex, and I get why it might seem intimidating.
It is a bit intimidating. The idea of an AI as powerful and versatile as O1, handling multiple modalities, adapting to any domain, it seems almost impossible.
It is a huge undertaking, but look at how far AI has come in just a few years. And remember, O1 started with those basic building blocks: policy initialization, reward design, search, and learning. By breaking it down, researchers are making progress towards that goal of multimodal and general-purpose AI.
That's reassuring, right? It's like climbing a mountain. It seems impossible from the base, but every step gets you closer to the top. Okay, so multimodal AI and its potential to change how AI interacts with the world. But let's circle back to those open source projects and how they're tackling these challenges.
Yeah, let's jump back into the world of open source development and see how these projects are trying to bring the power of O1 to everyone.
Okay, so multimodal AI, generalization, these huge ideas. But how are these open source projects actually making it happen? That's what I want to hear more about. It's amazing to think that this power, right, it could be for everyone, not just some big company or lab.
Yeah, that's the beauty of open source, right? Collaboration, innovation, rapid progress. We talked about O1 Journey and OpenReasoner.
Mm-hmm.
Let's dive back into those. And then there's also slow thinking with LLMs. It's in the
Wait,
paper.
visit them.
Yeah.
With multimodal AI and generalization in mind, how are they handling these specific challenges?
So with O1 Journey, one thing that really stood out, their focus on tailoring the reward model to O1's architecture. They found that this specific reward model did much better than a general one. It suggests that for an AI to generalize, right, we might need those adaptable, context-aware reward models.
So the reward model needs to get the nuances of different fields, adjust its feedback. Makes sense, can't be one size fits all.
Exactly. It's like a coach who can adapt their training to each athlete's strengths and weaknesses. Now, OpenReasoner, they were inspired by AlphaGo and its Monte Carlo Tree Search. This lets the AI explore so many possibilities, simulating tons of scenarios to find those best paths to success.
Right, like the AI is playing out every move in a game, learning from every outcome. But how does that connect to multimodal AI?
Great question. Think about how we experience the world, right? We use sight, sound, touch, all those senses to make decisions. For AI to really get it to interact like us, it needs to process and connect info from all those modalities, not just text.
So OpenReasoner's MCTS could be adapted, right, to explore not just text actions, but a multidimensional space with visual and auditory info too.
Yeah, precisely. It's about expanding what the AI can consider when it makes decisions, using a much richer understanding of its environment. Now, slow thinking with LLMs, really interesting project. They explored both reinforcement learning and knowledge distillation.
Right, they use knowledge distillation to transfer expertise from AI systems like QWQ and DeepSeek R1. What does that mean for generalization and multimodal AI?
Well, one key takeaway is this. Even with a few examples from those expert systems, their AI model got much better at complex reasoning. So knowledge distillation could be huge for quickly boosting AI in new fields.
So it's like giving the AI a crash course from the experts, right? Instead of starting from zero, it uses that existing knowledge.
Exactly. And this could be really valuable for multimodal AI, where the AI needs to process info from many sources, distilling knowledge from those AIs that already handle images, sound, etc. It could speed up development.
Wow, this has been an incredible journey, right? We started with O1's core components, then explored multimodal AI, generalization, the amazing work these open source projects are doing. The future of AI is so full of potential. It's exciting to see what breakthroughs come next.
Yeah, it's a great time to be following AI. And what's really cool is that this isn't just happening in big tech, right? Open source is a huge part of pushing the boundaries, making this tech accessible, so everyone can contribute.
This deep dive has been, well, humbling and energizing. Humbled by all this human ingenuity and ambition, but energized by AI's potential to change how we live, work, and understand the world.
I totally agree. And remember, this is just the start. Explore the links to these projects, dig into the research, keep asking those big questions about AI.
Thanks for joining us on this exploration into O1 and the quest for truly intelligent AI. Keep those minds curious and those imaginations going.